Hello, everybody. Welcome to this week's episode of the Day Zero podcast. Inspector with me is Z. And today we have some topics that touch on some various vulnerabilities in Ubuntu and Vaultwarden. And we have a bit of a follow-up discussion for fuzzing macOS kernel extensions. But first, we will talk about the Ubuntu issues. So this was a Qualys security advisory on some issues in needrestart, which is like a utility that ships on Ubuntu server and is used to restart the whole system if needed, or just some services if they need to be restarted. One example they give is if a shared library the service uses is removed or overwritten, it'll restart it. And these vulns come down to a feature they added in Need Restart 0.8 called interpreter scanning, which allows interpreter support for binary and plaintext source files for like Java, Perl, Python, and Ruby. And the need restart tool is interesting because in order to do what it does, it runs as root. And it'll scan all user processes, including untrusted ones, to do it. So the first bug here is with the Python interpreter, because need restart will, I'm not really sure why, but it will pull the Python path environment variable from the process's environment, and then will execute a hard-coded Python script. And if you have a malicious process that sets a malicious Python path, they can get that script executed with a malicious Python path, and they can simply plant a shared library in its script that'll do something useful as root, like pop a shell. So pretty straightforward bug. The second vulnerability is a little bit more complicated, but it was also in the Python functionality, though it also may exist in the Ruby functionality they point out, but they didn't dig into that too much. And this was a
It
talk
was
to.
confirmed, like it does impact
Oh, it
Ruby
was
also.
confirmed?
It's
Okay.
yeah,
From
I
what I
believe they
read, it
got
wasn't.
okay, they do have this last minute update there. CV has been assigned for the Ruby one also.
Ah, okay.
Exact same bug, and I did pull up the commit here. Yeah, it seems like basically just the part of the interpreter system here will just check if that Python path exists, and if it does, includes it in the environment that it's going to be using. I guess code I wanted to see isn't quite on here, but yeah, it basically just grabs the environment out from what it just like parsed out if it's present and just puts it in there. So borrows just decides to borrow it basically.
Bit of a weird design because they're basically treating the process's environment as trusted when it shouldn't be. Kind of the opposite of what you want to be doing. But
Yeah, like
I guess
it's
it was just easier to do it that way. I don't know, but yeah, it was a bit of a naive design and kind of brutal of a vulnerability in this case.
yeah, it's definitely a weird move. So it's been a long time since I have written any Perl. So I believe like when they're using this %env, like that is the environment for the entire process. When they're pulling that in here, locals just saying like let me access inside of here, and then when they're pulling it and doing the assignment, like I believe they're setting it for their own that process environment. I might be mistaken about that, but I believe that's what's going on. So it's not like using it to execute something else. I think we were talking about this a little bit about having the hard coded script, um, which it does kind of have its own, like it is writing out its own script into Python there. But yeah, it does seem weird on a whole. Like these bugs in general are a little bit surprising, but at the same time, Qualys has been doing this for a little bit, where they have been fine. Because obviously they did the pseudo bugs. They've had a number of these bugs that are kind of in core services, and feels a little bit like, and this is, I'm definitely not the only person that's had this or comment, but feels a little bit like there's just a lot of scary code that has existed for a long time. I mean, this is, I guess, somewhat newer because it is newer functionality of needs restart, but just this kind of glue code that exists that isn't getting very many eyes on because of the somewhat limited attack surface. The because the attack surface on like a bug like this does require that you're already like it is, it's not a remote attack surface. Obviously local
Yeah.
privilege escalation is always very useful and has its place. Seems to only require that you're able to run a process and this will scan everything. I was a little bit unclear about what it, like if it was scanning every process or if it, because it seems like when I looked at need restart itself here, it seems like it would work with the like system V or whatever
Like the core system
service scripts.
daemons. Yeah.
Yeah, like it seemed like it worked with those, but then it also seems like it's scanning all the processes, possibly as part of the interpreter stuff that was added. So yeah, I'm a
That's the
little
way
bit
I read it.
unclear on the impact, but it does seem like it is something that just if you can run code with a custom environment in this for this one, you would be able to abuse this. And they have a couple other bugs that I'm sure you'll touch on here momentarily, but
Yeah.
it just
Yeah, so I'll kind of circle back to that discussion because you did raise some interesting points, but I think I'll cover the other bugs first.
go for it.
So yeah, so the second vulnerability was also in the Python functionality. It was a time of check, time of use issue though, because when the interpreter would try to check if it is a Python process, the way it does that is it checks the exe file in the procfs for a given process, and that just tells you basically what the binary was that was executed through execve or whatever, and it will match it against a regular expression. And if it matches what they expect Pythons to be, they'll run that for the interpreter. And after the reporting of a previous issue, the regular expression pattern actually does seem to be pretty decent at preventing like a malicious binary from being ran in place of Python. The problem is there's sort of a double fetch where it'll read it once for actually using it, but when it checks it, it will read that exec file from procfs again. So you have that classic file system race, where if you change it between the use and the check, you can execve your own malicious binary and have it ran by needrestart. The last issue was in the Perl functionality and was a bit more of a straightforward one. It's just sort of a command injection in the scan depths functionality due to arbitrary input via the file name being passed to Perl's open. They state that this is sort of a classic issue to look for in Perl. I wouldn't really know. I've never really looked at Perl very much. I don't like it too much, but
The
if you're in that area, it seems like it's a fairly common sync. So
Yeah, the gist of it really is just the fact that when you provided the file name that ends with a pipe character, it's like, hey, this is a shell command, and therefore runs it as a shell command instead of just opening the file directly. It's just some of that like language magic.
yeah. So yeah, the vulnerabilities here aren't too complicated, and as you kind of said earlier, this has been in the discourse when talking about these issues lately. I think it came up quite a bit with the cups issues too, but it seems like Linux user space is able to kind of hide in the shadow of the kernel because over recent years, the kernel has received a lot of attention for, of course, remote attack surface like RCEs, but also local privesc because for a while, like the kernel has always been the kind of path of least resistance in a lot of ways, where it's like, especially when getting around like sandboxing and virtualization, because if you can attack the host kernel, you can just like that's where all the security is enforced. So you can just disable it and do whatever you want. So the kernel's kind of been the go-to target for local privesc, but you kind of have all these services running in user space that run as root that just don't get looked at as much, and the code quality is much worse. And I guess in a way like that kind of makes sense. Like you want to make sure the code running in the kernel is better because it has the potential to bring down the whole system, and like I said, that's where all the security is enforced. But the root level in user space that these a lot of these services are running at is basically just as privileged for all intents and purposes, at least until you start getting into like the more hardening like sandboxing mitigations like SE Linux, but you're not really finding that anywhere except for Android. So yeah, Linux user space, yeah, it is in a bit of a weird place where it seems like the code quality is still pretty bad, and even in new code that's being added, it's not very well tested or audited. And I mean, yeah, like if you can escalate to root, like you don't even it's almost sort of is the path of least resistance now. The only sort of problems that you might have are the differences between the distros. Like you might not have a universal root, so to speak, like with needrestart. Like you're not going to find that on every Linux system, but being able to hit Ubuntu server is still pretty big.
Yeah, and I'm not sure where else this is used because Need Restart does have support with like Pac-Man, so it may be seen elsewhere too.
Yeah.
But yeah, there's when it comes to the user space. Maybe it is something that's been looked at. Like it's not like, oh, nobody's been looking at anything here. Like no, there have been like Pwned Own has had Ubuntu on there, and like Ubuntu, I think it was Ubuntu desktop actually. Maybe it was server. Um
Yeah, and they took it off because it was so much of a problem.
yeah, like it's been there, so it's not like nobody is looking at this whatsoever, but it
But
does
not
feel a
as
little
many.
bit like, well, a lot of what I saw, and maybe this is just a bias because it was only what I saw coming out of Ponto, not everything that was actually there, were things that ended up being kind of like specific Ubuntu services were looked at. Whereas this, I think, is a little bit more like this is actually maybe it's not. I was going to say this feels like it might be a little bit more used, like if this came out Debian, but actually I do think this might just be out of Ubuntu, um, and not coming out of Debian. So maybe the spread isn't necessarily that wide in terms of how many places are using it. Yeah, I don't know. I guess what I'll say, but
But see, this is kind of the exact problem of why I think Linux user space is such a mess, is that between the distros and stuff, you don't even know what's running. Like you don't even have like a good baseline of what services are running on which distros. Like you just kind of have to guess at it, or like monotonously check every distribution and see what's running. And like there might be things that are installed but not running as default, but then on other distros they are running as default, like Ubuntu server. Like it's just such a mess trying to keep track of the attack surface for these sorts of areas in Linux.
yeah. So I will say there are S bombs that are starting to uh be adopted, which does kind of help with that. SBOM being software bill of materials, basically taking that whole idea of like a bill of materials with construction or something and being like, let's bring that to your software build or the actual operating system and all of the libraries, applications, and components that are involved there, having that. So I'm not sure. I think Ubuntu does something, or you can generate a list. I'm not sure offhand. I haven't looked too deeply into S bombs. It's not something that I've
Neither have
needed to
I.
do, but I'm aware that that is something that's kind of gaining traction and would help with that. Just in terms of like if you're trying to find a target that has a widespread, being able to see the S bomb for multiple distros and be able to compare things, because you could already like go with some that's core Debian and use that as like, you can impact all the things that fork off. There are kind of certain families of the distros you can refer to, but yeah, it is difficult. And if I'm thinking about, I'm going to guess someone like Red Hat, like Enterprise Linux, probably puts out an SBOM. Like probably you'd probably be able to get that to some degree, but when it comes to some of the other ones, maybe. Yeah, I don't know. I'd have to look a bit deeper into that, but that is at least a step in the direction of making that information more accessible without actually needing to install it and see what all is there, because that is a very tedious process. One interesting thing though is a lot of times when we've talked about prior bugs that were in some of these either core services or whatever, they were also happen to be written in C, and this does come out of scripting, like out of a scripting language, so
That's
kind of
true.
a
It's not
plus for
your like
that.
memory corruption sort of thing that you would kind of jump to for Linux services.
Yeah,
That
like
is they're more logical level issues, yeah.
yeah, and it does seem like this need restart is a newer project. Like it's still several years old here. I see this one README file here goes back at least 8 years, so it's not like a brand new project or something.
But in like Linux terminology, like within the last decade is considered new a lot of the time.
Pretty much, yeah. Like Linux definitely has some history there. No idea when it kind of started being adopted. Uh, because they mentioned this was kind of inspired by some that already existed with the Debian goodies or check restart and Debian goodies package. So doing that using actually before I say that, I'm just trying to see if I can find maybe a GitHub repo for check restart. I have no idea which one's the real one. I'm just curious if this is actually written in C, although this is probably not. That's a FreeBSD thing. I'm making a guess here that it's probably written in C, but I don't actually know, and I don't see a quick and easy GitHub repo to click and find that out. But at
So
least the
I
benefit.
found a I
Oh,
found a fork of Debian goodies check restart, and it's looks like a Python script.
oh, well. In that case, I'm just, hating on it for nothing. At least they are using a scripting language. Like, I appreciate that over seeing more C binaries coming out there. As much as I like C, I don't like seeing it used.
The real love-hate relationship. But
As a
yeah,
language, I don't mind it. As like a reality, we just can't do C correctly. We can't do C
no,
securely,
it's an
so
unreasonable expectation.
yeah, I'd rather see things just not even try using scripting language. And I mean, scripting does make sense for something like this, so fair enough. I was hoping this was a project kind of one of those replacement sort of deals, but maybe it's not. Either way, it does stand out in my mind being a scripting language issue. It's not. And like that Perl one with the pipe character, very, it's like a Perl gotcha. Time of check, time of uses, I feel like you could see those in a lot of places, like the top two
Anything that
there.
deals with the file system like that, yeah, it's
Yeah.
just so hard to deal with. So
Yeah, it's a common enough problem that we've talked about similar issues quite a few times. We've even talked about the environment issues before. I
yep.
think the other cases we've talked about have been stuff that would get passed through from sudo and stuff. Not quite the same, but like sensitive environment variables are a thing that you kind of need to be aware of when you're executing random software.
It's easy to skip over environment variables as an attack surface, like especially if you don't use them a lot in code that you write, because like a lot of the code that I write, like I'm not really using environment variables often, or if I am, I'm using it once and then like it's like a set and forget, you know? So unless you're like specifically thinking about it and examining it, it's kind of easy to skip over, and I feel like that's why you run into issues with it so much.
It's just, it's
It's kind
one
of
of
abstracted
those.
away from you.
Well, when it comes to some like Python, when it comes to a lot of software, like they offer support for a lot of environment variables that you're probably just unaware of. Like
Yeah.
it's a configuration provider, I guess, that is not necessarily immediately obvious. Like you don't know unless you find the documentation for it, you don't know what environment variables it's going to expect and what you need to strip versus what you need to leave in. Like trying to do that sort of parsing is very difficult. And try and make sure you don't pass things through. So like you could whitelist, and whitelist is always the ideal case where you only pass through things you know are going to be okay, and that is the ideal approach. But that isn't practical in a lot of cases because you don't know everything that you're going to need. Yeah, it's one of those like hard to enumerate surfaces because it's not always clear what environment variables are actually going to be read. Ideally, there's documentation. Documentation isn't always up to date. Uh, and so like the only thing you have to kind of get at ground source truth is to actually like monitor its attempts to read environment variables.
Yeah. So, continuing on to our next topic. So, we do have a auth bypass that was disclosed in Vaultwarden by Insinuator. Um, so, this was a bit of an interesting issue, and it has to deal with complicated login flows. So kind of the first thing they talk about here is how unexpectedly complicated the password and auth code checking logic was, which is something that we like to talk about quite a bit. And I know it's a particular favorite of yours, Z, so I'll let you get into it here.
Yeah, there's kind of a couple things I might call out with this one, but first of all, this is in Vaultwarden and not in Bitwarden. So Vaultwarden is like an open source Rust uh server that is compatible with Bitwarden. So like you could use the Bitwarden extension or clients or like their mobile app, all of that with Vaultwarden, but it is its own service, open source, written in Rust, trying to be a secure service. So it is different from Bitwarden, but it's related to it. So this vulnerability specifically in Vaultwarden. And the core issue feels a little bit silly. I can kind of understand how a developer fell into this sort of trap, but basically you have your normal login flow. That is the last thing in this. They have the code up here in the if else block, if some auth. Basically, if it has an auth request, it'll use that method. Otherwise, it's going to check and see if the password's valid. So that's kind of the thing you expect there to be in the login, is just that check password thing. And then you've got this auth request. The auth request is used for like login with device. It's like I'm trying to log in on the browser and I want to use my device to do that login. And you maybe have the QR code, you have some sort of process going on there. That's what your auth request is. And the auth request is how like the credential can be shared from the device to the user. I'd have to double check for the specifics here, but I believe basically auth request is going to have like its own public key. And when the provider, so the device that actually has the credentials, is going to encrypt its credentials among like a challenge. There's other things involved with this, but ultimately it's going to provide like that master key is going to get shared through this auth request to the user. And so when they're doing this actual login flow, they basically, if they fall into this auth request flow, they just check like, is the access code correct? Are they providing the right code? Is this sending like the right details? And they're not actually validating the information that's encrypted through it. And they're not actually ensuring that this auth request belongs to the username that they're actually trying to log in as, which ends up being the problem, because this auth request, basically you come through, it finds it gets the auth request, pulls it out, it checks the access code, and at that point, as long as the access code check was okay, it just falls through the rest of this, doesn't fall into the else. And since it already fell into one of the if statements here, it won't fall into the check password and just kind of carries on with the rest of whatever authentication code was there, authenticating them on the server as whatever user was there. The mitigating factor on this is that they're authenticated as that user. And the attack with this flow is just the fact that the auth request, it doesn't validate that it actually belongs to the username that you're trying to log in as. So if you take a auth request for like the attacker, they create an auth request for their own user and then send that in response to try and log in as some other user. It'll basically follow through all of this, it'll look good, and it'll log them in as that other user on the server. But because they don't actually have the key material, they didn't use the actual password, they didn't get that actual like password shared, they're not able to actually decrypt any of the user's information, any of those credentials, but they can still access and modify or delete them. So like there is a denial of service sort of attack where you can delete everything or modify and corrupt them, but you're not actually able to decrypt the data. So this is one of those cases where defense in depth, because they're making sure because you have this end-to-end encryption going on, even though the auth was broken, you're still not able to actually get the data. Now you could say leak this data, leak the encrypted data, and then try and do like an offline brute force of all of it, try and figure out what the key material was. Like there are some further attacks that could be done here, but that would also have to be done on like every single user that you want to attack with this. It's not something that's done at scale. You can't like dump everybody's password. Like you don't get access to the passwords. You still got to break the encryption, even though authentication was broken here. And it is also worth noting that 2FA multi-factor auth was not broken with this. So if that came up, that would not have been bypassed here. You'd still have to kind of go through that process. In terms of like how this happened in the developer, I can kind of feel like they expected this sort of bug to be caught later when the password didn't properly decrypt the actual data. Like just having that thought of, okay, well, they've got an auth request. The auth request is okay. If it's for the wrong user, like they're not going to be able to actually decrypt anything. And like that should just get picked up. There should be some sanity check decryption or something. And so the developer didn't really think. That's why I'd imagine maybe went through a developer's mind in writing this without doing that check for like the associated user to make sure the auth request is for the right user, just assuming that the failure later would get picked up, and it wasn't in this case. I don't know for sure,
I will say,
but go ahead.
That is a bit of a weird thing where it's like, whenever you're dealing with crypto and you have a thing where you don't have a clear indicator of like a failure, you have to do that sanity checking where it's like, if you try to decrypt the wrong key, it's not going to fail. It's just going to give you garbage data. And the onus is then on you to check if that data is supposed to decrypt to something. Like that sort of logic is kind of weird to try to handle from a developer standpoint. So like I can understand why they don't have that checking. So yeah, like thinking that that checking would be in place would be like that would give me pause personally, but I guess I could understand why someone else might think differently on that. But yeah, it is a good demonstration though of why using the password and whatnot as key material is a great idea.
Yeah, like in this case, even with the compromised server, like that break at that point, you still don't actually break the passwords. You get a step closer, like you get access to some of the materials that could then be used, get that brute force. There is one other attack here that is worth noting because it could potentially leak information. That is when you're dealing with organization. So, in addition to having like your own passwords encrypted, as I think most users are probably using it kind of on a personal level, if you're using inside of like a company, an organization, you might have an organization. And in that case, and then you'll belong to the org and have access to some subset of all of the things encrypted by that organization. That organization, though, will just have one key. And that key will be used to encrypt all of the things, whether or not you have access to it or not. And so if you use this auth bypass to attack another user who belonged to an organization that you belong to also, but had access to more or higher privileged or just other keys that you don't have access to, you would be able to read those and use the key that you have through your own account or through maybe another there's some other vector, whatever that you would require that organization's key probably through a legitimate means where you're part of that org and just accessing keys that you don't otherwise have privileges to access. That's, I think, probably the biggest impact of this one, just because of the fact the organization key is shared even across passwords or secrets that you don't necessarily have access to. And that access is basically only enforced by the server. So as long as you have that key material, you're able to decrypt those other secrets using this sort of attack where you'd get onto a more privileged user. So that is kind of a noteworthy usage of this. It does require you're part of that organization that you're attacking, though. So like that is a pretty privileged attacker already.
Yeah, I wouldn't say it's something that could never happen, but it definitely is like a very specific circumstance that would have to take place.
Yeah, it's like it is worth mentioning because like the thing about these sorts of bugs is this is where I think something like CVSS kind of fails to capture, and they didn't provide any CVSS here, so it's not like they were trying to claim something through that or whatever. But this is one of those cases where it's like the whole thing that Vaultwarden is supposed to do is protect those secrets, and so just being able to read them and violate some of that, it does make it a more severe issue. Again, that only for the organization, you've got all those caveats that definitely mitigate this one, but it's just one of those places where CVSS, where it's just like, well, it's only confidentiality, therefore, and not like, I guess you do have an integrity violation because you can change things without, yeah, I mean, partial, I guess. You've got some claims there, but either way, definitely an interesting bug and just one of those cases that also highlights the defense in depth aspect where just because the server got compromised and like you actually had an auth bypass, you still didn't really get away with what mattered.
Yeah. Now there was a little bit of an interesting situation with the attempt to fix this issue. I don't know if you looked into that too much, see.
Yes, I wasn't going to go too much into that, but yeah, they did the two patches on this. The first patch on it, basically they use the device identifier to try and say, well, does the user have this device identifier? But they still did that lookup using the auth request. So an attacker could still basically create this for themselves. And then they actually checked the user in their second attempt at patching it.
Yeah. Yeah, just kind of a funny thing. I wasn't going to go too in depth on it, but I thought it was a little bit funny as it indicates maybe the issue wasn't fully understood at first of what the problem was. because yeah, there was still nothing tying the auth request to the user. So I thought it was a little bit funny, but yeah, I mean, it obviously did get ultimately fixed in the end, but uh, yeah, again, another instance of things where fixing the vulnerability wasn't super straightforward on the vendor side.
Yeah, and it seems like the turnaround on this was relatively quick. So November 8th, they disclosed the vulnerability to the Vaultwarden team. That first fix came out on the 10th, and on the 11th, they uh or basically by the 12th, it was, actually fixed. Like they had the second patch in there. So like pretty quick there for like 4 days for two patches. Like definitely a good turnaround on that. Yeah, I mean the first patch is a little bit weird. I agree with you. It does seem like maybe just misunderstood what the issue was, or misunderstood the application of the device. I think there's a few things that could be there. I don't really have any good reasoning or any good
Well,
idea on that one, but it was a quick turnaround, so I'll still give him a win on that.
yeah, and I think it's sort of understandable with how many nuances there seems to be with that auth flow. The more complex you have the auth flow, there's so many like variables and relationships you have to look at, and yeah, I could kind of see how something would be overlooked in that way. So
Yeah, it is one of those things. Like it kind of ties in with something, one of those drums that I've hit on a few times, which is just like the weird auth states. And going through this auth flow kind of feels like one of those odd states to be in. Like it's maybe not that weird login with device, but it does create this, like it creates a different flow than what you might actually expect or what would be
you're
tested
trying to
by
mix the
somebody.
auth flows. So yeah, it's something like a separation helps a lot with stuff like that. So
Yeah.
yeah, it's fair to point out. And moving into some mobile AppSec, we have a post by Vorvex on from an Android hook to RCE. So this was targeting an Android app called My Arancel. It's used for an Iranian telecom company app. It's for like managing your account, paying bills, stuff like that. Fairly bog standard kind of app. And yeah, they talk about their process of discovering and exploiting an issue with a bit of a weird setup with using a headless browser on the server side. And I kind of asked you about this earlier, Z, but this isn't really a common setup as far as I'm aware. Like, I haven't really seen this in even other blog posts that we've covered on the show before.
Yeah, so the use of a headless browser is definitely common, but how they get here, I am just going to give listeners a quick summary on this is Earl first just mentioned if you kind of want more information about their flow and their thought process. One nice thing about this post is they are kind of just walking through their whole process here. I thought about this, so I did this, I did this. Here's how I approached this problem, or I ran to this problem, and how they beat their head against it for a while. There's a lot of that sort of information through this. It's a very kind of stream of consciousness sort of post. Do include a nice little SSL pinning bypass thing using a Frida hook that you can copy out if you want. Ultimately, this whole thing had like a custom encryption scheme with their own key sharing thing, so they didn't need to worry about like TLS or the SSL stripping, because, or I guess more generally, man in the middle, because they ran their own encryption on the data they were sending. Ultimately, they decrypt that, they work through all that obfuscation and figure that out, and they end up with this really weird data flow where there's some binary data here like null one. They try and figure out this, but they're trying to figure out at this point, they're just trying to do their login. I mean, ultimately, what they figured out is, and they figured some of this out through documentation, is that like they have this custom encryption, and what they're doing is they're communicating commands over to a headless browser that fetches the page, gets the HTML, can then execute JavaScript on that page, returns the page, which then gets returned to the mobile app. So it's kind of a remote browser sort of situation. Like it does remind me of that sort of a cloud-based browser sort of setup, which I've seen that before, but this whole system seems very over engineered. I'm not sure what exactly they're going for with this. And ultimately, just as they kept digging in more and more, like, or actually, to answer your question, like, no, I have not seen this sort of setup in the wild. Myself, I've definitely seen headless browsers used, but this sort of complex setup of like sending commands back and forth like this
Like
in
using
order to actually do
RPC
things.
on a headless browser. Like that's kind of like it's strange.
It's very like if I were coming in to do like a pen test on this, like one of my first comments would be like, maybe not on pen test. It would depend on when I was being brought on. Pen test, I be more focused on the testing. But if I'm brought on earlier when it comes to some of the decision making, would be like you probably shouldn't be designing this sort of very generic protocol to use that can do everything. Like that always
Yeah.
can like end up causing problems because it's just too powerful. As soon as somebody breaks this, they're able to start doing things that you never intended them to be able to do. It's kind of like feels almost like some of the serialization issues or deserialization issues and like that sort of thing. It's definitely not like it is its own thing here. This is not a serialization issue itself.
It has some similar themes though. I
Yeah,
agree.
it has like I feel like it has a similar vibe in the terms of like it's trying to do too much and allow everything, thus allowing a lot of things that you probably shouldn't. And yeah, like just architecturally, it would make more sense to just do like the normal thing, even if you keep the encryption, do like a normal like REST API and have that sort of thing. There's probably some back end reason why they went through all of this, but they definitely went through a lot. That's just a little bit weird here, ultimately letting them
Pretty much arbitrary JavaScript functions.
run
Yeah.
JavaScript in the headless browser. I don't think they ended up trying to see if there were any custom expose like or maybe they did.
They sort of did. So yeah, so for those who are listening and can't see like the stream, they have this kind of interesting gadget, so to speak, that the headless browser will use. So they have this WGT and then have arguments separated by colons. So the format that it has is like this WGT header, and then it has the path to the page, and then after that it has the function to invoke as well as any arguments that you want to pass to it. So that's how they're able to get that arbitrary JavaScript ran. Now, the server that was running this headless browser was not directly connected to the internet, so they tried doing like exfiltration through like XML HTTP requests, and that didn't work. They were ultimately able to exfil data through DNS. Because DNS requests, like if they weren't cached on like the internal server, they would eventually reach out to the internet, and they were able to use that to exfil data. So they used that to exfiltrate the page contents to get some of the custom JavaScript that was running on that browser. And they did find some interesting functionality that they tried abusing a little bit. So the one that they highlight is this load services function. It's a post authentication feature. And because like, this browser kind of assumes that you've already reached an authenticated state, it doesn't really have any additional checks. So yeah, they could call like into the internal web services, and they could do things like send a service SMS to like a user if you have their phone number and their sender name. They kind of wrote this whole like nice thing with ASCII art where they could dump the user's information, they could take over their account, they could send spoofed SMS messages. They could do a few pretty cool things because of the functionality that was built into the headless browser. So yeah, again, like those sorts of things, like they were only able to do that because they were able to exfil the page contents. Otherwise, we're pretty blind. You don't really know what to call into. You know, if you can get requests sent to your server and exfil that way, you know, they mentioned like in Node.js, you can just use the toString function to get source code. It wasn't really a big problem. So yeah, I mean, it's pretty cool seeing how they went from a basically a blind context to attack like a remote server like this and be able to get this level of access to like hijack other accounts and dump their data. Very cool in the impact. They do state obviously, they didn't want to go very far with it. They reported the issue and they didn't want to cause any actual damage, but it is good for demonstrating the impact of what could be done with their attack.
Yeah, and it's like I said, as a post, like it is a lot of just the flow and the information about their thought process, which is good insight to have. Even if you're not running into this exact sort of vulnerability, like we already mentioned, it is a bit of a weird setup. Yeah, that flow, that information is still worthwhile. Yeah, like the whole setup just feels so weird to me, like why they chose to go with this sort of headless browser proxy custom command system.
It's
Um
hard for me to come up with a charitable idea of why they would do it like this.
yeah, and kind of want to call it, like, they've mentioned that this has probably been the application had been tested by many well-known penetration testing companies before I began working on it. And so it feels surprising that the bug wouldn't have been picked up unless this was one of those cases where you're tossed on a pen test and the client doesn't do anything to actually make that pen test effective. And instead it's just like, yep, we've got this thing, here you go. Like, here's the app. And otherwise it's like black box. Oh, which on a pen test, like, you're usually time boxed. You usually have very limited time, set number of hours you're going to spend on it, and you get done what you get done during that, like, during the time you're getting paid for. Bug bounty, you're trying to get that impact. You're spending potentially more time on any one single thing. So if they had to deal with trying to figure out like the custom
Like the
encryption being
crypto,
used here,
yeah.
the protocol, once they figured out the crypto and like figuring out a lot of that, like, I'd understand why a pen test maybe was very superficial because the client, but I don't know if that's the case. That's just one thing that comes to mind, having dealt with a number of clients like that who treat the pen test, uh, or put up a lot of hurdles in front of pen testing, thinking it is supposed to be like a, I don't know, a checkbox, I guess. And, if they put a bunch of hurdles in the way, then it looks better on them rather than treating it as some they're actually trying to get value from and they wanting to help them find the issues. Anyway, I have no idea if that's actually the case. That's pure speculation, but it is
I
kind of
mean,
noteworthy. Like, go ahead.
it's still fair to point out that this issue is buried under like security through obscurity layers. So
Yes,
yeah, like
that's
if those are being treated as actual boundaries, then yeah, I could absolutely see how it would have buried this problem from being discovered.
yeah, because I imagine anybody with more knowledge on there should have been able to kind of pick it out. Like, there's probably something wrong with this whole architecture and at that level, but if you're having trouble even getting there, I could see a week long engagement maybe not even getting there in time if they had to go through a lot of these layers. It depends. Like, in practice, it's how you solve the problems varies and where you spend the time, because a pen test is supposed to be comprehensive and you're not just necessarily going to dig into one thing that may or may not pay out. That is kind of another difference between pen testing and bug bounty. Is bug bounty, you want to go deep, you don't have to. Like, there's different takes on it, but bug bounty often rewards going deep, and vuln research rewards kind of spending that time to get a really deep understanding, whereas pen testing tends to be a bit more comprehensive but not as deep, like
Yeah, it's more
wider
about going
breadth.
broad. Yeah.
Yeah. Yeah, so I don't know. Good post on a whole. Interesting bug, interesting setup there. Um, I guess I'll leave it at that.
Yeah. So we'll get into our last topic here, which is Project Zero. So Project Zero put out a post on simple macOS kernel extension fuzzing in userspace. So this is pretty closely related to a post that we covered last week or the week before. I don't remember exactly.
It was just last
But
week.
it was last week. Okay. So yeah, last week we covered the Pishi post. So that was a post by, wish I wrote down their name. I want to get it right. Right. Rootkit SMM. And yeah, so he put out a post on instrumenting kernel extensions to fuzz them more effectively. And the approach that he took was doing some of that binary rewriting some of the instructions to add the coverage, instrumentation calls, and things like that. And it went into a lot of background on like hooking on ARM and how they were doing a lot of that rewriting. But Project Zero took a bit of a different approach that they used to also find bugs. So we thought it might be a bit interesting to compare the approaches a bit. So this post doesn't go into as much technical depth as that post went into, but the overall strategy that Project Zero had taken was basically leveraging IDA to rebase a like kernel extension and then export the raw memory using IDA Python and basically write a custom loader and use TinyInst to instrument the extension and fuzz it that way. So instead of fuzzing in the like target environment in the kernel extension and rewriting it and getting it loaded, they instead chose to basically sort of emulate it in user space and fuzz it that way. And they found some bugs in AV1 code that they had reported previously that they mentioned. But yeah, it is sort of an interesting, different approach. They don't really go into the like differences of the approach. This is just kind of what they went with. They call out to the other approaches like Pishi at the beginning. But I am kind of curious, like how well each approach works, because you do have a lot of trade-offs when you're going from like fuzzing in the target environment compared to like emulating in user space. Because when you're running in user space, you can have a lot more performance. You don't need to deal with like context switches and all kinds of things that could impact your ability to fuzz. And of
You
course,
don't need to emulate the entire operating system anymore.
yeah,
It's just
you don't need to run the whole like dedicate the whole OS to doing that. And also, you know, any like crashes or anything you run into are a lot easier to recover from, and a lot of instrumentation also just is kind of designed around running in user space. It's a bit harder to do that in the kernel because of some of the constraints that you have with kernel programming when you have to deal with interrupts and all kinds of things like that. So you can have a lot of benefits in running in user space, but kind of the obvious big problem that you could have is you could run into some bugs that are like hallucinations in a sense. Although Project Zero does point out that they did actually. So at first, when they were actually fuzzing, and part of the reason they did it this way is they didn't have access to a machine with AV1 decoding, which is the specific subsystem they were looking at. So they kind of had to emulate it. They said eventually they did get like a MacBook with an M3 chip that supported that decoding, and they were able to successfully reproduce the issues. But that isn't always necessarily going to be the case, right? Whenever you're like porting things into user space, you could have bugs that just for whatever reason might not be practical to actually trigger in the target environment. But you could have like pretty notable differences in reliability if you're trying to actually exploit it. So
yeah, it
yeah,
really depends, I think, on how interconnected what you're trying to fuzz actually is with the rest of the system. Because basically, the more interconnected something is with the rest of the system, the more you kind of have to stub out. And it's in those stubs where I think you could have a lot of those compatibility issues when you try and move something into userland. And just because those stubs, may let you pass things through that wouldn't otherwise be passed through, and you're also kind of losing the entire flow. So there might be some checks that happen super early on that you kind of miss. It basically kind of comes down to the difference between like integration testing versus unit testing. Like this is usually when you see these sorts of user line fuzzers, they're taking kind of that unit test where they're testing a very specific area, get a lot more performance out of it, but they're not. There can be integration issues.
I remember some papers that we covered a while ago at this point. They called this microfuzzing, right? I'm not confusing that with something else. Like that was kind of the way they coined it.
Kind so that paper had nothing to do with like the idea of pulling out from like the kernel. That was just like we're going to fuzz this one function and like pulling single
like
functions
pulling
out,
down the granularity of what you were testing. That's kind of what I was getting at. Yeah.
Yeah, I believe that was, they called it micro fuzzing.
Yeah, I think there were a few papers that use that terminology, but
Yeah, I mean it's not necessarily a novel idea by any means to like fuzz the functions, but they might have been the first to. I don't know. When I'm Googling microfuzz, I'm unfortunately getting stuff about fuzzing microservices, which is not.
I mean, Google search gets worse and worse all the time, so it doesn't surprise me at all.
Oh, I mean, I'm not on Google search. I expect better.
Oh, right. Okay.
Either
sorry,
way,
don't have an excuse lined up then.
Yeah, I can't just blame Google being bad. But yeah, I mean, I've said my piece on that.
Yeah, I mean, it is interesting, and they kind of touch on this in the conclusion too. That this process is versatile enough that it allowed us to fuzz AV1 parsing code that normally requires hardware we didn't even have at the time, and that is really cool to do that emulated sort of fuzzing. But another issue that you can run into, and they talk about this in their posts as well, is you can run into issues where your harness in and of itself introduce bugs. And like you kind of mentioned this too, with like any functionality you kind of try to stub out, you could have issues in there that mess with your fuzzing setup, whether that be blocking it, like DOSing the setup basically, or just, causing those hallucinate, like false positives, so to speak. So yeah, it's sort of interesting comparing the two approaches. I think this method looks like it would be a little bit potentially easier to work with too, because where you don't have to deal with that kernel extension loading early on, you have a lot more introspection and debugging with this type of method, because again, you're in user space, you have a lot of tools that can deal with that, whereas before you're reliant on whatever level of access you have, and if you don't have any higher level of access, you're just kind of screwed. You don't have introspection into everything.
Yeah, and
So
there's just a lot more tools written to support user line fuzzing. Be that the instrumentations, be that, rewriting in like sanitizer stuff, like whatever. There's just so much more available on userland that makes it a very appealing option to do that, along with the performance gain.
yeah. So yeah, cool post from Project Zero. Again, it's a little bit short, and they don't go into all the technical depth of what they did, but it's definitely worth considering, and you know, maybe using as a point for arguments for trying to do some, like trying to change fuzzing setups a little bit, and exploring some new options. So
Yeah, it's nice to
yeah,
see actually these two posts kind of coming out back to back, because you get
yeah,
the PC one that is very just kind of like goes really deep on a lot of different topics and why they made the choices they made. This one doesn't go as deep, but you get to compare the two different approaches, which is nice to see. Just they're doing kind of a similar thing, so they're doing it doing a similar thing but going about it in different ways. So you get that perspective on like, what works, what doesn't work, or like, why they made those decisions. Yeah, it was interesting.
so with that said, that's all the topics that we have for this episode. So unless you have any parting thoughts, see, we'll probably wrap it up there.
Nope, I think that's good for this week.
All right. So as always, thanks goes out to everyone who tuned in, and we'll see you next week.